Let's take a look at this problem. A pizza shop sells whole pizzas and slices of pizza. The shop must sell fewer than 15 whole pizzas per hour. The shop can sell no more than 25 items per hour. The shop sells a minimum of 5 slices per hour. The shop must sell at least 5 whole pizzas per hour. Given that the shop earns a profit of $4 per whole pizza and $1.50 per slice of pizza, how many slices should the store sell per hour in order to earn the maximum profit? As always, we start off by defining the variables. Let X be the number of whole pizzas sold per hour, and let Y be the number of pizza slices sold per hour. Now we need to translate each of the statements into an appropriate inequality. So the first one, the shop must sell fewer than 15 whole pizzas per hour, translates into X less than or equal to 15. The shop can sell no more than 25 items per hour. That restricts the total number of things they can sell. So between slices and whole pizzas, X plus Y has to be less than or equal to 25, which we can then rearrange into the Y equals AX plus B form, Y less than or equal to negative X plus 25. The shop sells a minimum of 5 slices of pizza per hour, so that's X must be greater than or equal to 5. The shop must sell at least 5 whole pizzas per hour, so that means Y must also be greater than or equal to 5. And as always, we can never have negative sales of pizza slices and pizzas, so X must be greater than or equal to 0, and Y must also be greater than or equal to 0. Now let's look at the graph of each of these inequality statements. So the first one, X less than or equal to 15. We look at X, 15, and we've said that it's going to be less than, so it's on this side of the line, and it's a dotted line because it's only less than, it doesn't include the equal sign. The next equation, X plus Y less than or equal to 25, that's the black line going down here, and again it's going to be less than, so when it's less than, it means the arrows go underneath. X greater than or equal to 5, so here's X equal to 5. The arrows go to the right because that's where the numbers are greater than 5. The next inequality, Y greater than or equal to 5. So here's Y equal to 5, and it has to be above that line. And then finally, we need to take into account our X and Y axes, and we said it has to be greater than those. We can't have negative numbers. So that gives us all of the inequalities we're dealing with. We look to where all of the shading overlaps. We've got to be above the purple, to the left of the green, below the black, and to the right of the red. That gives us this area here that's shaded in green. We've labeled all of the vertices. Here's A, B, C, and D. And now we're going to go ahead and calculate the X and Y coordinates of each of those vertices. So for vertex A, the two lines that go through vertex A are X greater than or equal to 5 and Y greater than or equal to 5. We change those to equalities, X equals 5 and Y equals 5, and we don't need to do anything more. It's given us that X is 5 and Y is 5, so that's our vertex. Going to vertex B, the two lines that go through vertex B, Y less than or equal to negative X plus 25, and X greater than or equal to 5, we change those two equations, and again use substitution to solve. This time we substitute the 5 in for X, and so we change that to Y equal to negative 5 plus 25, which is Y equal to 20. Vertex C, the two lines that go through vertex C are Y less than or equal to negative X plus 25 and X less than or equal to 15. Change those to equations with equal signs, and again relying on substitution, we take the negative 15 and we put that in for X, and we solve, we get Y equals 10. So that gives us a vertex of 15, 10. However, we saw from the inequalities that we've got X less than 15. It doesn't have less than or equal to. So because it doesn't have the equal to, that's why we have the dotted line. When we have the dotted line, we can't use that number that's on the dotted line. So we have to go to the next closest number. And in that case, we can look and we can see that if we just move a little over here, we've now got 14, 11, which is very close to the 15, 10. That gives us a solution, so that's what we end up using. Instead of 15, 10, we go with 14, 11. Now we go on to vertex D. Following the same process, this time we've got the intersection of Y greater than or equal to 5 and X less than or equal to 15. We change those into equations, and thankfully once again we've got two equations which just give us x and y coordinates. So we've got 15, 5. With 15, 5, however, again, we're dealing with just an inequality. There's no equal sign there. It's just less than. So that means we've got a dotted line again, intersection with a dotted line. And with an intersection with a dotted line, we can't pick a point that is exactly on the line. So we need to go to a point that's nearby. In this case, we're just going to back up. We could move over to 14. We could move over to 14, 5, or we could go to 14, 6, as long as we're staying within the polygon of constraints and are very close to the vertex D. So we've determined all of the vertices. We've got coordinates x and y for each of the vertices. Now we need to identify our target objective and then write out an optimizing function that meets that target objective. In this case, we were asked how many slices should the store sell per hour in order to maximize their profit. So the target objective is to maximize value, to find the maximum value. To determine the maximum profitability, we look at how many pizzas they sell, how many pizza slices they sell, and multiply them by the profit that they make for each one. So they make $4 profit for each whole pizza that they sell, and $1.50 profit for each slice of pizza that they sell. So adding those together, that gives us the total profit, which is the optimizing function. Now we take that optimizing function and we take the vertices that we found in the previous step. We take the coordinates of each vertex and plug that into the optimizing function. So into the profit equation, we got 4x plus 1.5y. We take the 5x, substitute that in, put the 5 in for the y, and we calculate it, we get 27.5. We do the same for the other two vertices, and we come up with the total values for each one. Now we can go through and look at each one and figure out which one gives us the largest value, and it's clear that 72.5 is the largest value, so that is the maximum profit that they can make. Once we've figured that out, that gives us the maximum. We know at which vertex that occurs. Now we need to just summarize to answer the question that was posed during the initial problem and say that the pizza shop must sell 11 slices of pizza to earn the maximum profit.